Morning all. Morning students. Respond anybody? Opendev, Arshita. Morning students all. Am I visible and audible for you? Anybody respond? Anybody respond? Am I audible and visible for you? We'll start now. We'll start the division of new chapter, Nuclei. Okay. In this chapter, it is a very small chapter, and 4 marks will come from this chapter. Totally, how many marks are coming means 4. In this 4, one mark question will come and one 3 marks question will come. How this distribution will be there means 1 mark and 3 marks. Then what are the important 3 marks questions in this chapter? What are the important 2 marks and 1 mark? So 2 marks we can split them into 2 parts and there is a chance of asking 1 mark. How the questions they may ask we will discuss now. So what are the 3 marks questions in this chapter? What are the 3 marks? First one, write the 3 characteristics of nuclear forces. Write the 3 characteristics of nuclear forces. Okay. Nuclear forces are charge independent, like that 4-5 properties will be there. Write any 3, that will be 3 marks question. Next. Second question will be write the differences between nuclear fission and nuclear fusion. Write the differences between nuclear fission and nuclear fusion. That will be second question. Okay. These two questions are enough in this chapter regarding the 3 marks. Totally one mark question, one 3 marks question will come from this chapter. Okay. Already you prepared this question. If you are not prepared, try to prepare these two questions. Clear? Next, what are the 2 marks questions? Total 4 marks. Total 4 marks. In that, one mark question will come, one 3 marks question will come. 3 marks questions, you just prepare these 2 questions. What are that? What are the characteristics of the nuclear forces? Write the differences between nuclear fission and nuclear fusion. These 2 questions are here. Next 2 marks questions, one by one we will discuss. Take the notebooks and note it down, all of you. That will be useful for you. Okay. First one, 2 marks questions. These are what are isotopes and isobars? What are isotopes and isobars? This question may be asked like, what are isotopes? Give examples. What are isotopes? Give examples. One more in the same. What are isobars? Give examples. Like this, same format. What are isotopes and isobars? What are isotopes and give examples? What are isobars and give examples? While writing the nuclei, how we will write X, Z, A. In this format, we are writing that X, Z, A. Here X will be the symbol for the nuclei. Z will be atomic number. A will be mass number. So this will be mass number. This will be atomic number. Z will be atomic number. A will be mass number. Okay, now see. So I will tell one simple technique to remember this. So in XZA, here in XZA, what we are doing is atomic numbers we are writing at the bottom. Mass numbers we are writing at the top. Mass numbers we are writing at the top. Atomic numbers we are writing at the bottom. Isotopes means, remember this top word. Isobars means, remember this B. Tops are not same. Those are called as the isotopes. Just for your remembrance. No need for confusion. That's why I am saying that. Tops are not same. Top means this one. Atomic numbers are not same. Remember this B in the bars. B means bottom, like that you remember. Bottoms are not same. Not same. Those are called as the isobars. So technically, how for remembrance, that is the technique to remember for you. So how we will define the isotopes means nuclei having same atomic number. Nuclei having same atomic number and different mass numbers. Tops are not same, I said. Nuclei having same atomic number but different mass numbers are called isotopes. Okay, they are having same atomic number, different mass number. Example will be 1H1, 1H2, 1H3. 1H1, 1H2, 1H3 are the examples. They are having same atomic number, different mass numbers. Now, what are isobars? Nuclei having same mass number but different atomic numbers are called isobars. Nuclei having same mass number but different atomic numbers are called as the isobars. Example, tritium you take 1H3, helium 32 you take. These two are having same mass number 3, 3. Their atomic numbers will be different 1, 2. So these two will be called as the isobars. So nuclei having same atomic number, different mass numbers are called as the isobars. Nuclei having same mass number but different atomic numbers are called as the isobars. Hope it is clear for you. Next, see the second question is what are isotopes? Use examples. What are isotopes? So for this nuclei having same number of neutrons, nuclei having same number of neutrons but different atomic numbers are called isotopes. Nuclei, they are having same number of neutrons, but they are having different atomic numbers. They are called as the isotopes. What is the example for this? If you take examples 1H3 helium 42. Then here what is the number of neutrons? 3 minus 1, that will be equal to 2. 4 minus 2, that will be equal to 2. 3 minus 1 is 2, number of neutrons. Here in helium 42, number of neutrons are 4 minus 2, that will be equal to 2. So these are called as the isotones. This is the second question. Next, see the third one, what they are giving. Write down, define atomic mass unit. Define atomic mass unit. Uh, write the value of 1 AMU in kgs in kg. Define atomic mass unit. Write the value of 1 AMU in kg. Okay. Answer 1/12 of mass of 1/12 of mass of carbon atom C612 is called 1 AMU. 1/12 of mass of carbon 6C12 atom is called 1 AMU, and 1 AMU value in kilogram 1.67 into 10 power minus 27 kg. 1 AMU is equal to 1.67 into 10 power minus 27 kg. Okay. Hope all of you do this one. Next, what is meant by mass defect? Give the equation of mass defect. Wrote this one, all of you. Next. Fourth question. Define mass defect. Define mass defect. Give the equation of mass defect. Give the equation of mass defect. So answer right only. The difference between the masses of the nucleons. The difference between the masses of the nucleons and mass of nucleus is called mass defect. The difference between the masses of the nucleons and the mass of the nucleus, that will be called as the mass defect. Give the equation of mass defect. So mass defect formula, mass defect delta M is equal to ZMP plus A minus Z into Mn minus capital M. Mass defect formula ZMP plus A minus Z into Mn minus capital M. That is the formula for it. Then, what are the terminology in that? Where Z is equal to atomic number Np is equal to mass of proton A minus Z is equal to number of neutrons. Mn is equal to mass of neutron. Write down this one. Z is equal to atomic number. Mp is equal to mass of proton. A minus Z is equal to number of neutrons. Mn is equal to mass of neutron. Next, capital N is there. Capital N is equal to mass of nucleus. Capital N is equal to mass of nucleus. So, this is one question. Okay, these 2 marks questions may be asked as 1 mark question. How? Define mass effect. That will be 1 mark. Give the equation of mass effect. That will be 1. There is a chance of asking. Generally, 2 marks question will be a combination that may be split and it may be asked as 1 mark. Okay. These questions are previously asked in the examination relating to this chapter. Next, 1 mark questions, some are there. We will discuss that question. One marks. Yes, simple and easy chapter. Already I told you 1 plus 3. 1 mark question, 3 marks question will come in. If your preparation is according to the blueprint given by the board, definitely all of you will score more. Next, write this question. What is the ratio of the nuclear densities? What is the ratio of the nuclear densities of two nuclei having mass numbers in the ratio 1:2? Two nucleic mass numbers are in the ratio 1:2. What is the ratio of nuclear densities? We know nuclear density is independent on the mass number. Nuclear density is independent on mass number. Therefore, density is ratio 1/1. d1 by d2 is equal to 1/1. d1 is to d2 is equal to 1/1. If you write just this line, that is enough. No need to write this one also for your understanding. Nuclear density is independent on the mass number. d1 by d2 is equal to 1/1, or d1 is to d2 is equal to 1:1. Next, write that question, all of you. Second question. Second, what they are asking, give an example. Give an example for conversion of mass into energy. Give an example for conversion of mass into energy, where mass will be converted into energy. So answer for this will be nuclear fission, nuclear fusion, nuclear fission and nuclear fusion. Energy mass will be converted into energy. Where mass will be converted into energy means nuclear fission, nuclear fusion. Next, third question. Who discovered neutron? Who discovered neutron? What is the answer for this? James. Hey, James Chadwick. Who discovered neutron means James Chadwick. Okay. Okay. However, innocent fellows, Chadwick discovered. Next. See the fourth question. Write down this, wrote this one, all of you. Okay. Next, fourth question. How is the radius of the nucleus? How is the radius of the nucleus of an atom? How is the radius of nucleus of an atom related to its mass number? Relation between radius and mass number. What is the answer for this? R is equal to R naught into A power 1 by 3. R is equal to R naught into capital A power 1 by 3, where R naught will be a constant. No need for this, right? Where R naught is equal to 1.4 Fermi constant, that is 1.4 into 10 power minus 15 meter. R is radius, A is mass. Okay. Let's see the fifth question. What they are asking, how does the nuclear density depends on the size of the nucleus? How does the nuclear density depends on the size of the nucleus. Nuclear density is independent on the size of the nucleus. Answer for this: nuclear density is independent on size of the nucleus. Nuclear density is independent on size of the nucleus. Write this question, all of you. Okay, just 2 questions are there still. Totally 7 questions are there. We have to take 5 minutes. We will confine this class. Next, five completed. Next 6. Define binding energy of a nucleus. Define binding energy of a nucleus. So write down. It is the minimum energy required. It is the minimum energy required to remove all the nucleons from nucleus. It is the minimum energy required to remove all the nucleons from nucleus. Okay. Last question. What is nuclear force? Right. It is the strongest attractive force. It is the strongest attractive force that holds the nucleons together in the nucleus. Is the strongest attractive force that holds the nucleons together in the nucleus. Is called nuclear forces. Okay. So with this chapter revision is completed. Just 1 3 marks question and 1 mark question will come from this chapter. Easy and simple chapter. Easily you will get 4 marks from this chapter. How many marks are allotted? Easily you will get that marks. Still one more chapter is there. Semiconductor devices. Wednesday we will discuss that chapter. Once with that total 1 marks and problems are completed, We'll go to the important 3 marks and 5 marks questions in each chapter gradually one by one. Okay. Today we will confine this class now and head into the next class. Okay.